Hello everyone. In this video, I will be discussing contains duplicate problem. This is mentioned as third array problem in the 75 LeetCode problems. So yeah, let me start. Yeah, so I follow these 8 steps in each of the problems. And yeah, let's start with the first step, which is read and understand the question. So, okay. Given an integer array nums, return true if any value appears at least twice in the array, and returns false if every element is appearing only once. So here I can say that input is a vector of int, and if it contains duplicates or not, then we return out is a boolean value. And if we see that input is a vector of int, it can be any nums, and all we have to do is figure out a way to say if a duplicate exists or not. So yeah, I think the question is pretty straightforward. Yeah, and fourth step is write test cases and edge cases for it. So if we see the array can be empty with 0 element, it can be 1, it can be greater than 1, I would say. So let's say it just have 1 element. In this case, we should return false because the item is only 1 present and there's no duplicate of it, so false. If there's nothing else, then yeah, duplicate does not occur, false. And for anything more than one, we have to solve it. Algorithm. I think these are 3 cases. Whatever the value inside is doesn't matter. I think it's integer, so it will be negative, positive, 0, anything it wants. Yeah, it is. Yeah, it's given here. Yeah, it's an integer. So yeah, after we have clarified these 4 things, now let's think of a brute force solution. So brute force solution we can do in n square. Let's say brute. So what we're gonna do is we can let's take an example. 1, 2, 3, 4. Let's say 1, 2, 3, 4, 5. Now let's take up this example. Now, brute force solution is you can just pick a value and check in the remaining of the array if that value comes again or not. If it does, then return a boolean of true that duplicate occurs. If it doesn't, then just keep going forward. So we start from I equals to 0. We pick this. We go I equals to 1, and then we look for the next ones if duplicate, like when we go I equal to 0, 0's value, the value is 1. So we'll be like, all right, from here to here, does 1 occur? If it doesn't occur again, then yeah, we'll continue, keep looking. For I equals to 1, we'll pick up 2, and we will search for 2 from here to here. Then I is equals to 2, we'll pick up 3, and then we'll search for 3 here to here. And then same goes for 4, and same goes for 5. 4 will be this, and 5 will be this. So basically, we'll run this loop, and every time we'll see if the ith element occurs in the remaining of the loop. If it does, then return true. If it doesn't, then at the end we'll return false. So for code of this, what we can do is, like, let's say for 0 I less than, let's say nums dot size I plus plus, that will be a one loop. Then if in this will be like for int j is equals to 1, j less than nums dot size j plus plus, and then we can just say, here we can say int current is equals to nums I, and j should be starting from I plus 1. And here we can say if we can just say nums of I is equals to nums of j, return true. And if this is the entire block, return false. What we're doing here is this loop will run n times, this internal loop will run n minus 1 times, and anytime this condition satisfies, we're going to return true. If it doesn't satisfy, then yeah, just a second. This loops and here this loops. Yeah, I need to. We're going to return false from here. If this code doesn't exist, that executed, that means we never found the item in the duplicates in the entire array. So at the end we return false. Now n minus 1 n square minus n is equals to n square big of, this is the time, space complexity of this is big of 1. So that's something we don't have to code it for in front of the interviewer, but we can always explain that yeah, this is the brute force solution. And now the next step is, for efficient solution, what we can do. So we are iterating the loop twice in this solution. That's why it's big of n square. Now, is there a way efficient that we only need to iterate through this loop once and then we can figure out our solution? So there is an efficient solution. But like we have to decide a trade-off between space and time. This code has high time complexity but less space. The one that I'm going to suggest right now is it will have faster time, but it will also have a big off on space. So it's some trade-off that we have to do if you want time or space based on the size of the input, or time matters to you most, whatever the situation arises to. Mostly we focus on the time complexity because we want our solutions to be processed really fast. So yeah, that's how efficient solution comes out. But so what I'm trying to do here is take a map, hash map. So actually, rather than taking a map here, we can also take a set, hash set. So the set will always consider only one item at once, no duplicates. So let's go to again let's take an example. So this is an example. So what we're going to do is, for I equals to 0, we're going to see if 1 exists in the hash. So initially it's empty, it doesn't. Then what we'll do is we'll put that 1 in hash set. And let's say this value is 1, the 1, 2, 3, 4, 1. Then for I is equals to 1, we'll say current value is 2, does 2 exist in the hash set? 2 doesn't, so we'll do 2. And then I equals to 2, 3. Does 3 exist in the hash set? No, it doesn't. Then we'll enter it and then move over. I equals to 4. Does 4 exist? It doesn't. Then we'll move forward. I is equals to 5. 0, 1, 2, 3, 4. Actually, yeah, sorry. 3, 4. I is equal to 4. We'll be like, all right, currently is 1. Does 1 exist in the hash set? They'll like, yeah, it does. So we'll return true here. In hash set, insertion and find is big of 1. So the code will be let's say set of integer, you can say st for int I equal to 0, I less than nums dot size I plus plus. If let's say auto it is equals to st dot find, and then you can say nums I. If it not equals to st dot end, that means we found the number, so we'll be like return true. Else stack dot insert nums I. That's going to be the code for this, starting from here to here. We are creating a one map, one set. Worst case, this will be, actually let me do this. Worst case space complexity it will take is big O of n. This loop will run for big O of n size, so time is big O of n, space is big O of n. Now, yeah, let's code this algorithm. So we can say set of int, let's say int, let's say st, then we can say for int I equals to I less than nums dot size, and then we say auto st, auto it is equals to st dot find, and then we can say nums I if it is not equals to st dot end. We're going to return a boolean here, which is true. Else we are gonna do stack dot insert nums. We don't have to insert indexes, we have to insert an entire number itself. And then worst case, so let me return. So we created a stack. Now let's see if 0 and 1 is covered. If the nums is empty, this will not be run. Will return false, which is true. Nums is 1. This will be run, but it will not find anything in the stack. So if this is true, if anything more than 1, this should run. I is less than nums dot size. This is good. Iterator stack dot find nums I. Not equal to stack, and then this is good. Okay, let's run. Alright, this looks good. Let's quickly keep it a little bit improvement. So it's 37% and 88. Let's resubmit. Yeah. This changed. But yeah, that's the solution for this. Let me know in comments if you have any questions. Thank you.